Hello everyone, I am Sachin Haridas Rohane, Assistant Professor. In this video, I am giving some information regarding proton pump inhibitors. Now let's start the discussion. Proton pump inhibitor. So these are the agents which block the action of proton pump. First of all, let's see the normal role of proton pump. So the final step in the acid secretion in the parietal cell is the pumping of proton into the lumen of stomach by the membrane hydrogen potassium ATPase pump. Thus, the inhibition of this proton pump acts beyond the site of action of a second messenger and is independent of the action such as the histamine, gastrin, and acetylcholine. Thus acid pump inhibitor, that is the proton pump inhibitor, block the action such as the basal as well as stimulated acid secretion. So generally this proton pump inhibitor block both the actions, that is basal as well as stimulated acid secretion. So in this way this proton pump inhibitor will act. Now let's focus on the some actions of that is proton pump inhibitor which having lead nucleus, that is benzimidazole. The most important thing is that this proton pump inhibitor are prodrug. So it means that they produce active metabolite. They are rapidly converted to a sulfonamide intermediate. This is an active metabolite and which is highly acidic environment they will produce of a gastric parietal cell. The weakly basic nature of benzimidazole accumulates in this acidic compartment of the luminal side of tubovesicular and canalicular structure of parietal cell. The benzimidazole proton pump inhibitor are then chemically converted by acid to a sulfonamide, and that sulfonamide will inhibit the proton pump via covalent interaction. This proton pump inhibitor inhibit via covalent interaction with sulfonyl group with cysteine residue. This cysteine residue of proton pump, right? Then all these proton pump inhibitor, right? They have been shown to react with cysteine 813. This is a residue unit, that is cysteine 830 of pump. So this is common one, right? So the compound is also bound with another other residues. These are the examples that I have given here. For example, omeprazole and esomeprazole, they will bind also with cysteine 892. Then pantoprazole will bind with cysteine 822. Then lansoprazole will bind to the unit, that is cysteine 321. So this example bind with cysteine 813, but also bind with the mention which is previously. Right. So these are some examples which bind with the cysteine residue. Now let's concentrate on the location of this cysteine residue. The cysteine 321, then 813 and 822 are in the proton transport domain of the hydrogen potassium ATPase system, whereas the cysteine 892 is on external luminal surface and does not affect pump transport ability. The bioaccumulation and the activation of proton pump inhibitor within the acidic environment of the parietal cell is also ensure the specific pharmacological action. Now check on the again some different aspect of proton pump inhibitor. So the acid liability of this benzimidazole proton pump inhibitor dictate or indicate that this drug must be formulated as delayed release or enteric coated granular dosage form, right? Because of their acid liability. Now till date there are 5 structurally related benzimidazole proton pump inhibitor available in the market. Here I listed some examples. That is omeprazole, esomeprazole, then lansoprazole, pantoprazole, and rabeprazole. This proton pump inhibitor, they are differ only in the nature and the degree of pyridine as well as the imidazole ring substitution. And this substitution change or the variation in substitution definitely affect on pK value. And ultimately when pK values changes or differ, so this pK value definitely affect the pharmacokinetic property of drug. So I am ultimately again repeating same thing. these changes in the imidazole nucleus or pyridine nucleus affect pKa value. pKa value affecting pharmacokinetic. So pharmacokinetic means the absorption, distribution, metabolism, excretion. So definitely it will again affect the pharmacological action. So now check out the importance of pKa here. The rate of conversion of proton pump inhibitor to their active sulfonamide. Why active I am supposed to say? Because they are showing the action as it is a product. So however is determined largely by the pKa values of a benzimidazole group. Right. So here I mentioned some pKa values of some examples, that is omeprazole showing the pKa value 4.06, rabeprazole 4.53, then pantoprazole 3.83. So this pantoprazole having pK value lowest compared to other other proton pump inhibitor. So ultimately the proton pump inhibitor having more pK value shows faster action, shows faster formation of sulfonamide compared to pantoprazole. So that's why the pK plays important role in pharmacological action. Now let's see the different examples of proton pump inhibitor. Now this is first example, that is omeprazole. Here there is a general structure of omeprazole, it indicating the IUPAC nomenclature indicating that it's a benzimidazole derivative. So this is chemistry. Now check out the ADME. The absolute bioavailability of orally administered omeprazole is found to be near about 30 to 40%. And when we consider its substantial first pass of biotransformation. So after biotransformation, the value found to be near about 30 to 40%. The primary active metabolite of omeprazole was found to be 5-hydroxyomeprazole, and most important, omeprazole sulfone. So these are the active metabolite of the omeprazole. Then check out the mechanism of action, how it shows its action. So this omeprazole will show the irreversible inhibition of proton pump. So no doubt they will block the action of proton pump. In this way there is a decrease in secretion of acid. Now lastly, the uses of omeprazole, where it is useful. So no doubt it is useful in heartburn, then GERD, that is gastroesophageal reflux disorder, then all type of ulcer, like for example duodenal ulcer, then erosive esophagitis, then gastric ulcer, and it is also helpful, that is in a pathological hypersecretory condition. So this is the uses of omeprazole. Now this is a second drug, pantoprazole. Now check out the chemistry and the structure. So this is general structure of pantoprazole. Again, it's a benzimidazole derivative. Now ADME, pantoprazole shows viability near about 77%. When we administer this pantoprazole with a food material, its absorption may get affected, but its viability never get affected. When we see the metabolites of this pantoprazole, it is observed that O-demethylation with a subsequent sulfonation type of metabolite will observe regarding pantoprazole. So this is ADME about pantoprazole. Now check out the mechanism of action. No doubt it is similar to the omeprazole. Again, it irreversibly inhibit proton pump. So ultimately block the action of proton pump. Now let's see the uses. So again, it is useful in heartburn, GERD, duodenal ulcer, and it is also useful for gastric ulcer as well as a Zollinger-Ellison syndrome. So this is the uses of pantoprazole. Now this is third drug, that is rabeprazole. Now check out the chemistry and structure. So this is the structure of rabeprazole. Again, it's a benzimidazole derivative. Now check out the ADME. Rabeprazole sodium is formulated as a entry-coated or a delayed release tablet. Why it is so? Because one should safely crosses through the stomach in intact form. That's why it is formulated as a entry-coated tablet or a delayed release tablet. When we consider its metabolite, it shows thioether and sulfone as a primary metabolite. Now just check out the mechanism of action. No doubt it is just similar to that of omeprazole as well as pantoprazole. It's showing action that is irreversibly inhibit the proton pump. So ultimately decrease or ultimately block the acid secretion. Now check out the uses of rabeprazole. Again, it is useful. Again, similar manner, heartburn, GERD, duodenal ulcer, gastric ulcer, and Zollinger-Ellison syndrome. So in this way, I have covered or I have given the information regarding the proton pump inhibitor. Firstly, we have just check out the role of proton pump, then the different mechanism through which we can block it, then the several aspects regarding the benzimidazole proton pump inhibitor, and lastly we have covered three different examples. So in this way, I have concluded the proton pump inhibitor. So thank you for watching.